For much of the 20th century, German automotive engineering was widely regarded as the global benchmark. Manufacturers like Mercedes-Benz, BMW, Volkswagen, and Porsche built their reputations on precision, durability, and technical sophistication. German engines were known for their refinement, their mechanical complexity, and their ability to deliver consistent performance when properly maintained. This reputation was not based on marketing alone. It was supported by decades of engineering tradition, strong industrial infrastructure, and a culture that valued technical rigor. Within this context, complexity was not seen as a problem. It was often viewed as a necessity. If a system could be made more precise through additional components, sensors, or mechanical solutions, that approach was usually considered valid. Engineering excellence was closely associated with advanced design and detailed control over every operating condition. During the 1960s and early 1970s, this mindset worked well. European cars were designed primarily for their domestic markets, where maintenance standards were high and driving conditions relatively predictable. Reliability was important, but it was often secondary to refinement, performance, and driving experience. At the same time, the Japanese automotive industry was developing under very different conditions. In the decades following the Second World War, Japan faced severe resource limitations. Space was limited, materials were expensive, and waste was unacceptable. Japanese manufacturers such as Toyota, Honda, and Nissan focused on efficiency, cost control, and long-term durability. Their cars were not designed to impress through performance or luxury. They were designed to function reliably for as long as possible. In Europe, Japanese cars were generally perceived as basic. They were often described as inexpensive, simple, and lacking character. While their reliability was acknowledged, they were rarely taken seriously as engineering achievements. They occupied a different segment of the market and were not considered direct competitors to German brands. This perception began to change in the late 1970s. The oil crises of 1973 and 1979 altered global automotive priorities. Fuel efficiency became more important, especially in the United States. Japanese manufacturers were well positioned to respond. Their smaller, lighter cars with simple engines gained significant market share. More importantly, data from the field began to accumulate. Japanese cars were showing unusually low failure rates. Engines were lasting far longer than expected. Warranty claims were lower. Maintenance costs were predictable. Vehicles often reached high mileage with minimal intervention, even when maintenance schedules were not followed carefully. Initially, European manufacturers explained this performance in simple terms. Japanese cars were less powerful, less refined, and therefore under less stress. Their engines were simpler, and simplicity was assumed to be the reason they survived. But as the data continued to grow, that explanation became insufficient. By the early 1980s, German manufacturers began to investigate more closely. This investigation was not public. It was conducted quietly, through internal benchmarking processes that were already common within the industry. Cars from Japanese manufacturers were purchased and tested extensively. They were driven for long distances, often under harsh conditions. Afterward, engines and components were removed and shipped to engineering centers, particularly within Volkswagen, Mercedes-Benz, and BMW. These engines were dismantled completely. The goal was not to admire design innovation. It was to understand wear, failure modes, and consistency. Engineers measured clearances, inspected surfaces, analyzed materials, and compared results against European engines subjected to similar testing. What they found was unexpected. Japanese engines, particularly those from Toyota and Honda, showed remarkably consistent wear patterns. Components aged evenly. Failures, when they occurred, were predictable. There were fewer catastrophic breakdowns and fewer random issues. The engines themselves were not technologically advanced in the conventional sense. Many used simple single overhead cam layouts. They relied on straightforward mechanical solutions. The number of components was often lower than in comparable European engines. At first glance, this simplicity appeared unimpressive. However, closer examination revealed careful decision-making. Materials were selected conservatively. Designs avoided unnecessary stress. Systems were not pushed to theoretical limits. Instead, they were optimized for real-world conditions. German engines, by contrast, often demonstrated exceptional performance and refinement, but they were also more sensitive. Small deviations in maintenance, operating conditions, or manufacturing variation could lead to problems. Complexity increased the number of potential failure points. This difference was not primarily a matter of engineering talent. It was a matter of philosophy. Japanese manufacturers approached engine design with the assumption that users would not be perfect. Maintenance would be inconsistent. Operating conditions would vary. The engine had to tolerate this reality. German manufacturers, historically, assumed a more controlled environment. Engines were designed to perform optimally when treated correctly. When those assumptions were not met, reliability suffered. As more Japanese engines were analyzed, the pattern became impossible to ignore. The consistency did not come from any single design feature. It came from the way engines were designed, manufactured, and assembled. This led European engineers to look beyond the engine itself and examine production methods. At the center of this system was the Toyota production system. Developed over decades under the influence of figures such as Taiichi Ohno and Eiji Toyota, the Toyota production system emphasized the elimination of waste, reduction of variation, and continuous improvement. Quality was built into the process rather than inspected at the end. In this system, simplicity was not a cost-cutting measure. It was a risk management strategy. Fewer parts meant fewer opportunities for failure. Standardized processes reduced variation. Assembly workers were trained to identify problems immediately rather than pass them downstream. This approach extended to engine design. Engineers worked closely with production teams. Designs were evaluated not only for performance, but for manufacturability and long-term consistency. If a feature increased complexity without providing proportional benefit, it was often rejected. European manufacturers began studying these methods more seriously in the 1980s. One of the most significant points of contact came through NUMMI, the new United Motor Manufacturing joint venture between Toyota and General Motors in California. The factory used Toyota's production methods, but employed American workers. Engineers and managers from Europe observed the operation closely. What they saw challenged many assumptions. The equipment was not fundamentally different. The workforce was not uniquely skilled. The difference lay in the system. Problems were addressed immediately. Processes were standardized. Responsibility for quality was distributed across the entire organization. This reinforced what German engineers had already observed in Japanese engines. Reliability was not the result of superior components or advanced technology. It was the result of disciplined execution. Throughout the late 1980s and 1990s, German manufacturers began adapting aspects of these methods. Lean manufacturing principles were introduced. Quality control became more data-driven. Unnecessary complexity was increasingly questioned. This did not mean abandoning German engineering identity. Performance, refinement, and innovation remained priorities. But reliability and consistency gained greater importance earlier in the design process. Engines became more robust. Systems were simplified where possible. Manufacturing variation was reduced. The gap in reliability between Japanese and German vehicles narrowed significantly. By the late 1990s, Japanese manufacturers were no longer viewed as inferior or merely practical. Their engineering competence was widely recognized. German manufacturers, in turn, had integrated many lessons learned from studying Japanese production and design philosophies. The simple Japanese engine that once seemed unremarkable had played a role in this transformation. Not as a technological breakthrough, not as a revolutionary design, but as a practical demonstration of what disciplined engineering and controlled production could achieve. The discovery was not a single moment, nor the work of a single engineer. It was a gradual process, repeated across laboratories, workshops, and factories. Each engine dismantled reinforced the same conclusion. Reliability was not accidental. It was engineered. And by the end of the 20th century, that lesson had reshaped the global automotive industry.